Okay. Hello, everyone. It is a very, very wet day here in the Pacific Northwest. We have one of those atmospheric river things going on, and so it is pouring rain outside, which, although it is usually quite wet here in Portland, it is not usually like this where it's pouring rain. This is a lot of water. We even have a flood watch. It's kind of crazy. Um, anyway. Today we're gonna dive into and look at some ways that we can classify imagery. So a couple of weeks ago, I had a newsletter where I talked about different AI tools in ArcGIS, and somebody wrote me an email saying, "Hey, what about this other thing?" And he was asking about vision language context, which is another way to do image analysis in ArcGIS. So then last week's newsletter was kind of a deep dive into uh, the three kind of broad categories of classifying imagery in ArcGIS using AI. And so I wanted to take today to kind of walk through some very specific examples of a few of those things. So, we're going to go ahead and get going here. Share. There we go. Okay. So, this is my newsletter from last week, episode 42, which is all about classifying imagery in ArcGIS. And specifically, I covered kind of three different ways you can do this. Using a domain specific model. So that is something that is trained specifically to extract a certain type of information, whether that's ships in the ocean or cars in parking lots or building footprints. It's designed specifically to do one task. Then there's the segment anything model, which you can describe what you want it to extract, and it will extract polygons for you that try to match what you described. And that's quite useful, but not quite as good as domain specific models, but not quite as generic or as flexible as the last one, which is vision language context. And that's what ArcGIS calls using a large language model to do image extraction or image classification. And so I went through this, and there's this whole section here on object detection versus classification. So when we're classifying or yeah, it's classifying imagery, we might be looking at uh, an image and then trying to get like land cover information out. Um, or we might be just trying to understand what's in the image. For example, does this image contain a stop sign? Right? Or we could be trying to do object detection, and that's where this comes in. And I want to actually be able to draw a box around something like a bottle or a laptop and say, there is a laptop in this image, but not only that, this is where in that image this laptop is, right? And so this same thing, the same principles apply whether you're looking at an image of a desk or you're looking at a satellite image of some land, whether you want to extract the building footprints or you want to extract all of the swimming pools or anything like that. Those type of processes all kind of they follow the same things. And actually, what's kind of interesting is that if you look at the GIS models that are used to do these kinds of image extraction or image or object detection in images, they're often based on the big industry models like YOLO or other types of models that are built on not even images of satellite data. They're built on just images of things with information in them, and then they're fine tuned on that information. And so basically in this newsletter, I walk through kind of these different models, when you can use them, how do you choose them? Okay. What kind of started this whole discussion off was this example that I had in episode 39 a few weeks earlier about image analysis. And in this image analysis example, I have this web app where you can zoom in and you can uh, ask it to analyze the image. And we looked at this a little bit in our last live stream, but we're gonna look a little bit more here. So this is that web app, and so I'm gonna zoom in to the Gulf Coast somewhere down here, and we're gonna do kind of uh, an obvious test so that you kind of get to see how accurate or not accurate it is. So we're just going to ask this to extract for us grass, trees, and water. And we're just going to hit run. And so what's happening here is we're taking this image and we're sending it to a large language model to extract information. We're going to look at how that works in just a second because it's pretty straightforward. Um, so we see that um, it totally didn't do it right. When I was testing this before, it was definitely working. But you see what it did is identified 50% of the image as grass, 39% as trees, and 11% as water. And I think it's gotten confused because this isn't blue. This is like ocean. So we're just gonna like scoot over here and maybe we're gonna try this again just to see what it does. Uh, um, but that's a little bit better, but let's see here. It provides a description of what it did. So based on the satellite imagery analysis, I can identify distinct patterns in the grass, trees, and water distribution. Analysis shows clear boundaries between surface types, showing signs of recent change or disturbances. Okay, so it's not. Um, oh, huh. Why is that not working? This was working. That's exciting. Uh, it's a live demo, so things go haywire. Um, Fascinating. Let's just refresh it. See if we can make this go. Okay, let's see what happens here. No, it's still, what is going on? Uh, Fascinating, exciting. Okay, we're gonna do one more thing. I'm gonna go back and just reopen the app here from scratch and see if this makes any difference. Because it might be that it has some kind of cache problem. Because I wanted to show it working so that I can show you the model. No, it is. Well, that is so weird. Okay, what have I done? This is definitely here. Huh. So weird. Okay. Huh. Now I'm slightly this is weird. I don't what's happening. AI image analysis, edit. We're just gonna play with this for a minute. This is what live demos are for. We're just gonna play with this and see if we can fix this really quick. Because this is important. And also it does work. Oh, whoops. Somehow I have it hooked to the test endpoint. That explains why it's not working. I wonder how this worked a minute ago. That's weird. That's fine. No problem. All right. Here we go. We're going to do it again. We're going to do it again. It's going to work this time. I have faith. Get zoomed in pretty far here. Water. It's taking longer. That's a good sign. It's a good sign that it's taking longer. Okay. So what's happening here is it's took a screenshot of this map, took this map right here, and it sent it to this webhook in N8N. And I'm scared that it's not going to work, so I'm not going to change tabs until it finishes, but I'm going to show you the workflow in a second. It takes this image and it sends it to Claude, and it asks Claude to analyze it based on these three criteria and return back the percentage of content for each one of these things. So there we go. So this makes more sense. Water 55%. You can see I kind of strategically positioned the beach line at about the middle of the screen. So that makes sense. 8% trees. Yeah, some of these might be trees, but they might just be kind of scrubby bushes, and 25% graph. So, or grass. Graph. That's funny. So we're going to let's look at the analysis. Aerial image, so coastal area where water dominates the lower portion of the frame, about 55% of total area. Ocean, seawater, clearly visible, greenish blue coloration, blah, blah, blah. Okay, so it basically, the remaining 12% consists of beach sand, bare earth, pathways, and what appears to be a tidal inlet. Oh yeah, there we go. Okay, so pretty cool. It described the map and it gave us some kind of rough estimations of the makeup of our map here, which is pretty neat. So the way this works is this workflow takes an image and it extracts out that image, but it also extracts out the categories. So the list of categories that I defined here in this box, that's the one that didn't work. I'll close it. That I defined in this box here, it takes those and it uses some JavaScript here to kind of break those up and define an output schema, basically saying what type of output we want. And then it sends it off to Claude. So we're using Anthropic's Claude here. And we have a very simple prompt. We're not doing anything super complicated that says, analyze the uploaded image, blah, 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 and specifying the list of categories that we wrote in the UI. And then we have a system prompt here that gives it a bit more background about being a GIS analyst and things like that. So when we run that, we get some output JSON that we format, and then we just clean that up for final execution. So if we look at this, we can look at this last run we had here, and we can see it uploaded a screenshot. So there's our screenshot of the map. So you can see that matched our thing just before. And then we can see our output from the model here is those same numbers followed by an opinion about its justification for those numbers. And that was the same text that I read in the UI. Okay, so that's pretty cool, right? So I can very easily kind of generically build some image analysis on an image like this. And just building a workflow like this and using a large language model and just prompting it to do something. So how does this relate back to episode 42 in that I think that the power of using these large language models means that things like our segment anything model are going to become less and less useful as a specific tool, right? If you need super accurate things, these domain specific models are still the right answer. But if you need something fast, going straight to a large language model like the vision language context can often get you an answer much quicker. And you don't have to have a machine with a huge graphics card or go rent one in Azure or AWS. You can run this on your own machine because we're just calling an API. Okay, so that was all very cool. But as always, I was trying to figure out how can I take this type of process a step further. And I thought, well, it would be really cool if beyond just guessing at percentages, it could identify things in the image. And I've been playing around with Google's AI Studio a lot recently, specifically to use this AI image generation and extraction model that Google calls Nano Banana Pro. I don't know where they come up with these names. Na- Nano Banana Pro. I don't know. It's great. So I've been experimenting with generating images for this, which I will come back to at the end here with this little side project I've been doing. But in the meantime, I wondered if it could be used to do kind of basic image analysis. And so the first thing I did is I uploaded just a screenshot of an area. I don't even remember where this was. I think it was in Houston because I keep using those neighborhoods there because they're very clean neighborhoods for testing. Uh, I think this was Houston. So I just uploaded a screenshot of some satellite imagery. And all I did was I asked it to draw a red line around every house in this satellite image. And it did that. And you can see its thoughts here about what it did and examining the final image for compliance. And that's actually kind of cool that it does all that kind of built in. Um, but here you can see is our same image with red bounding boxes around everything that it thinks is a house. Okay, that's really cool. So I thought, how could I build that into a web app? How could I make that something that you could actually use? And so I basically went back to the same process as before. So I wanted to build another N8N workflow that could take an image. Okay, so this same thing. So you can see down here on the bottom, I have an image of a bunch of houses. And if we look at the other information we were sent in the webhook, we can see we also have an instruction, draw a red line around each swimming pool. Okay. So that's pretty straightforward. So we basically in our workflow here, we go in and we clean that up. Um, and actually I'm going to switch over here so we can look at the code. And all this is some JavaScript that extracts the instructions out of the image or out of the webhook, excuse me, and sticks some other instructions in here. So I'm basically just giving it kind of a root set of instructions that I want to help guide it, right? So analyze the satellite imagery based on the instructions given, always return an edited version of the image, don't reply in text, and the instructions are, and then whatever the user gave me, right? So in our case, our example, draw a red line around all of the swimming pools. So we take that and we kind of basically clean that up and extract the image out of the uploaded data. And then the result of that is the instruction, an encoded image, what type of image it is, and what size the image is, because there are some limitations on how big of a file we can send to this API. And then we just do a few basic things. Does it have an error? Did we get everything from the end user? If we did, then we're good to go. Do we need to resize the image? So was that image larger than our 10 megabyte threshold? And if it was, then we're going to run some extra code, resize the image, clean it up, and then continue with the workflow. But if it wasn't, then we don't really need to do anything. We're just kind of cleaning up our format here with some code, and then passing that on to Gemini. Gemini is the real name for Nano Banana Pro. So the actual image we're using is Gemini 3 Pro Image Preview. That's the real name of Nano Banana Pro. And we're basically just sending a JSON blob up to this endpoint. So we're not, just like I would be sending it to an ArcGIS REST endpoint or anything like that. We're not doing anything overly complicated. We're going to send that image and our prompt up, and what we're going to get back is an image. And what happens is we clean that response up a little bit, extract out what we need, find out if it was blocked because of safety content filters, etc. Basically just cleaning all of that up and prep the image for delivery to the user. Again, just using a little bit of JavaScript. And I will admit, I did not write any of this code. All of this code came from Claude. And I actually used Claude. Let me see if I have it open here. I used Claude to generate this entire N8N workflow the first time. And so if we go, actually, let me just look at, here we go. So if we look at what it generated, so um, Gemini Nano Banana N8N, I think this is it. So it actually generated the JSON workflow that I was able to just import into N8N and then tweak it, which is incredibly powerful because it basically means that with I get something to start with, and what it basically gave me was this whole workflow here. There was an extra step in here that was unnecessary that I had to delete. And then I basically just started testing it. I started at the beginning, I sent the information in, and I started stepping through this workflow, testing each step until I could get to the next one. And there was some cleanup to do. It wasn't perfect. Um, this parse input needed a little bit of help. So I worked with Claude, going kind of back and forth, rewriting this code block maybe 2 or 3 times until we got to the place where it is now. And then yeah, and like I said, there was an extra node here that I deleted, and I had a little bit of trouble specifying the parameters for the Gemini API at the beginning. It ended up that we were just specifying, we had like the capitalization wrong on one of the parameters. Um, but a little bit of back and forth with Claude, and I had basically this whole workflow built, which leads me to my first audience participation question. Um, in the future, would you all like to see me actually build one of these workflows live? Like actually go through the process of pulling up Claude, going through it, building it, pulling it in here, and then troubleshooting it, uh, knowing that it might not work. Because sometimes, okay, you guys are overwhelmingly saying yes. Okay, we will do that next time. I will actually just build one from scratch. Um, but I make no promises as to actual functionality. It might not work. But we will do that next time. Um, so basically what we do is we go back and forth with Claude to generate these different pieces. We put it into N8N and then we test it. So at the very end here, we do our last processing where we're just I think I already covered this, but where we check for safety and make sure something wasn't denied or anything like that, and then we package up our final output, and then all we do is if it was successful, we return that final image. Okay, now if we if we just took that image and we just opened it, that would be something we could do. Like I go over here and look at this example that we looked at before. Remember that our input looked like this, and we were asking it to find all of the swimming pools. And our output uh, looks like this. And that is probably a little bit hard to see. I don't think I can actually, I don't know if I can, I don't know if that works. Oh, it totally did. So you can see it drew a red circle around every swimming pool. It got most of them, missed this one down here, missed this one maybe. That one's a little weird anyway. How do you have a swimming pool like that, like wrapped in your house? Okay. Anyway, um, so it did a pretty good job of finding all of these. So we have this image. So what are we gonna do with it? Well, this is where I was like, well, if we have an image, and this is fun, right? So if we had an image, remember we had this one, we took this screenshot. We know exactly where we are, right? We can take a screenshot like this, and we know the extent of this map. If we know the extent of this map, the ArcGIS JavaScript API has this wonderful thing called a media layer, where I can put any image directly into my web map, just giving it the bounding box or the four corners. So that gives us the satellite annotator. So what we're going to do is we're going to go zoom in down here, and we're going to find some neighborhoods. And we'll do one at like this level, and let's see if we can find all of these lakes. Draw a red box around each lake in the image. We're gonna see what happens. Okay, so what happens here, right? We just went over this workflow. So we take this image, we extract it, we send it to that AI process, which just kind of cleans it up, and then sends it to Nano Banana Pro and asks it to draw a red box around each lake in this image. And what we should get back is an image with a red line around all of these things that look vaguely like lakes. And we did. And you see, the last thing we did is we took that image and we plopped it right back onto the map. And this dark shading that it did, actually, that's actually part of the image. So Nano Banana Pro did that itself. And so you can see it found a lot of these lakes. I think that is also a lake right there, and it kind of missed it. Um, but it found the big ones, so it did pretty good. Well, okay, this I think is wrong. That, yeah, those are trees. There are little lakes kind of on each other end, but those are trees. It definitely got confused by that. So not perfect. Okay, so let's do something else here. If we come over here, maybe we zoom in a little bit like this, maybe here, and we say something like, draw a box around each single family home. And we send that off. We should get back. Oh, I didn't even tell it what color. We'll see what it does. We should get back another map that has those things drawn on it. So this is super cool. I'm really happy with that. This was so easy to put together, actually. Um, how about solar panels? That might work. We have to find a place with some solar panels. Uh, I don't know. Okay, so it did it in black this time. Uh, but you can see it drew black bounding boxes around each of the homes. So it's actually pretty good. It drew a lot of them. Some of them are kind of like footprints, some of them are bounding boxes. That's okay. I wasn't super specific about what this would look like. Okay, there are solar panels in the extent right now. Seriously? I'm blind. Well, oh wait, there's some right there. Okay, let's see. This is gonna be fun. Uh, draw a red line around each solar panel. I'm never sure whether to say all of or each. It's kind of like open to interpretation when you do something like that. And sometimes when you say all, it totally just draws like one big box. Sometimes you have to say each. It's very it's kind of human-esque in that way. Uh, so that's kind of fun. I'm super curious to see what happens here. This is going to be fun to see if it gets us solar panels. I'm skeptical, but I am always surprised. Okay. I don't, I think it like drew solar panels. I I love that it like drew a little grid on each of these. That is hilarious. Oh my goodness. Um, so I think maybe these are solar panels. Maybe that, or maybe that's a shadow. I can't tell. I don't think it actually found any that are any good. Um, oh, it did find, oh, that might be solar panels right there. I think this house has solar panels, and I think, yeah, so it found one. It found one, and it made some up. So, so there we go. You can do that. It might be possible with some fancy prompting to make it better at that. I'm not sure. That might be a case where a real model is gonna just simply outperform it. Um, I don't know. The fact that I'm struggling with it makes me think that it will struggle with it. Uh, uh, because I would rate myself as only average finding solar panels. Um, but anyway, that's okay. So I'll keep want to keep messing with it, but I'm gonna keep going for right now. We maybe if we have a minute time, we'll come back and play with it some more. Um, so this was really cool. I liked this. I had fun building this, and it was pretty straightforward, right? Because we basically uh, um, sending a prompt and an image off to Nano Banana, having it interpret my prompt and the image, and then return an image back to us with some red lines on it, right? But it's just an image, right? And like it's just a raster. It's a PNG. It's not super exciting. I can't really do a lot with it, but visually it was very useful. So that got me thinking, could I take an image with a bunch of red boxes in it and extract those as features, just the red boxes? So you probably know what happened next. I went to Claude and I said, can we do this? But can we do it in the web browser? And the answer was yes. It turns out there's an opencv.js, which totally can do this kind of filtering. I actually struggled to get that to work. I think it's some kind of conflicting import between opencv.js and ArcGIS. I could not get it to resolve. So I had Claude write it for me. And that leads me to Satellite Annotator version 2, which I'm just going to refresh here. And we're gonna go. I'm just gonna keep using Houston because it works kind of works fairly well. I'll go up here somewhere, find some new spot. I don't know. Here we go. So let's say there's a bunch of swimming pools. So let's say highlight all of the swimming pools in red boxes. And so this first part is actually exactly the same. We take the image, we send it to the exact same workflow. We do nothing different. All of the magic actually happens in the browser after we get that image back. And I'll show you how I'm actually doing this. It's really rudimentary. And we're probably going to see it fail spectacularly in at least one case here. But this was like an hour's worth of work with going back and forth with Claude. If you could get OpenCV to work or do something fancier, it would probably be much better. Okay, so extracting swimming pools, it did a pretty good job. We picked up a whole house there, but not bad. Not sure that's a pool. I missed that one. Missed that one over there, but did pretty okay. That might be a pool, not sure. So it did pretty okay though. Let's do extract red boxes. So 98 red outlines. Let's just turn our image off. And sure enough, there are a bunch of features. So let's take one of these that's pretty straightforward example. This one here. If we just look at this spot, I'll zoom in a little bit. We just look at this one and we go back to the image. So this is the result, or let me go. So this is the original image that we had in our web map. This is the image we got back from Nano Banana. And then this is the feature that we extracted locally in the browser from the Nano Banana output. So nice and like pretty crisp, pretty clean. You can see it was able to extract that red box nice and easy. This is a feature. I can click on it and it's actually a feature graphic in the map. And this like over the top pop up here is only to prove that it is actually a real graphic. Now there are some weird things that happened. Let's go look over here. So this is kind of a mess. If we turn our image back on from Nano Banana, we can see there's two boxes here. There's one here and there's one here. There's not any over here, and there's not any here, and there's not any over here. But when we switch back to our extracted outlines, we're finding all those. So what happened? If you look very carefully here and here, and a little bit here, the image is actually tinted red. And so what it means is that my algorithm for finding red outlines in my image is needs some fine tuning. And that's really what happened here. It did not it was uh, overly selective. It picked too much red. So let's just take a quick look at how that actually works. So if we go look at our code here, um, so this is just my personal app building website that I use that is trained on the ArcGIS SDK 433 and makes it easy for me to build very quick applications like this. But if we go look at the code down here, we can see we have this function extract red boxes where we pass in an image, an extent, and then a height and a width for the image. And we go through kind of loading it up and getting the image data out and then doing a red mask. So if we go down and we look at red mask, we'll see what happens here. We go through, we take in red mask, we take in our image data, we build a big array, and then we process that data trying to figure out which pixels are red. And if we look down here, this all depends on is red pixel. And if we look down here, there are three ways that it's picking up red pixels. One is it more red than green or blue, right? It's an RGB image. Or is it red dominant? Even so, if all three numbers are low, but it is mostly red. Um, or doing an HSV, a saturation style analysis to see if it leans red. If any of those are true, then it calls that a red pixel. And then it basically uses that mask to find those bounding boxes. So when we go back to this, we can see that, yeah, right there, it found red pixels. They were predominantly red. And so it drew a line around them. Same thing in some of these other areas here. And if we kind of turn those off, it's a little bit sus. Like, does that really, you can't see my finger. I'm pointing. That it's a little bit sus. It's not red. It's probably just saturated red or predominantly red. It's not super red. But that's what's happening. So with some refinement or using ArcGIS tools, you could totally extract these red boxes as features. And so the thing that I think is actually really cool about this is I was able to construct this pipeline in a few hours. I can ask it anything. So I can, even if it's not like, say my feature extraction isn't perfect, that's fine, whatever. But I could use this regular one and I could ask it to, we tried solar panels. I kind of want to try solar panels again. I'm going to move over here and turn this off. Draw a red box around any roof mounted solar panels. This image is from the Houston area in Texas, and I don't know what else to give it. Does anybody have any other prompt ideas, any other stuff I should just throw in here to see if it gets better at solar panels? I'm not sure this is actually going to get any better. We'll just try it. I don't think it's actually going to get much better. Solar array, that would have been that's a good idea. I already sent it though. We'll do that again. We'll try it again. But anyway, what I think is really fun about this is I can use this to extract a lot of things. So I could ask it to give me sidewalks, for example. I could just ask it to draw a blue line on everything that looks like a sidewalk, or draw a red line down the center of all of the roads. So I can do a lot of those things. And once I have a raster with that information in it, I can go back to ArcGIS and I can do that. I can do those same, I can do kind of my traditional raster analysis, right? To convert that red line into a polyline or doing something like that. So I can gives me a very flexible way to kind of do this, even if it is like pretty interactive. Like I could totally turn this into a toolbox tool. Chris, request timed out. It didn't actually time out. I'm not sure why it does that sometimes. That's what you get when you do a live demo. Um, but anyway, I think this is actually quite powerful. And this is very similar to what Esri actually is doing in vision language context, which if we go to the Living Atlas and we look at this toolbox here, vision language context-based classification. So this is a deep learning package in ArcGIS. Excuse me. This is a deep learning package in ArcGIS that they can use a variety of large language models to do data extraction. And the output is a feature class, and you can see it gives you bounding boxes and they kind of overlap. And that's because it's not doing what we're doing. What's actually happening here is um, it's actually chunking the image based on an input feature class. So you give it like parcels and it cuts each image up and it's like, oh, this is one parcel's worth of data. I'm going to send one clipped image that is one parcel to OpenAI or to Meta or whatever AI you're using, and get back, is this damaged, missing? Is it building missing or destroyed? Is it heavy damage, minor damage, no damage? And then symbolizing after that. So uh, it works a bit differently than ours. Ours is actually asking the AI to draw bounding boxes or draw red outlines, and then we're extracting that out of the image. But fundamentally very similar. And you could totally do this process whoops, this process that we're doing here, timed out again. Totally do this process here in a toolbox tool, right inside ArcGIS Pro if you wanted to instead of on a web map. I just like it's nice and it's a good demo when you can do it online like this. Um, okay, I'm gonna try solar array. I'm gonna try saying that. It's not actually failing. If we go look at one of these previous, oh, that's not it. Where's our, there we go. Um, oh, it's taking 30 seconds. There might be a timeout set in there. So let's look at our input. So we had this image as our input here, and I think this is going to be a solar panel one. Yeah, draw artificial mounted solar panels. Let's just see what our output looks like. Okay, show. Oh, it doesn't have where's the binary? Oh, it's not showing me the binary image. It's all base 64 encoded, unfortunately, which I can't view easily here. Oh, there we go. Okay. So here's our solar panels. So I don't know. That's not solar panels. That's not solar panels. That also is not solar panels. So it's just not doing a great job here. Wonder how it would do on utilities or manholes. It might do pretty good on manholes. Segment anything does pretty good on manholes. And the fun thing about something like a manhole is you can describe it as a manhole, but you can also describe it as like a circle in the middle of a street. Um, and so by kind of giving it different classifications or different descriptions like that, you can often get different types of results. So um, we could probably find a place that has manholes somewhere. I wonder what place would have manholes. I feel like there should be manholes. Huh. This is weird. I guess even with like buried utilities and everything, I would expect there to be manholes. somewhere. Anyway, I think that it would work with manholes. I think that would be kind of an interesting test. Um, so anyway, it's kind of crazy to me how powerful these out of the box models are getting because like this is just a large language model. This is a large language model that you can open your chat app with on your phone and talk to, and the same model or related model, I should say, in the case of Nano Banana, a related model is really good at doing GIS. It's not even been trained on doing GIS. It's trained on generating realistic pictures of things. So it's like, it's not even trained to do this, but we can totally use it to do this type of analysis. And I think although its accuracy might be like maybe 50%, maybe even worse, it's incredibly powerful because it's so fast to product. So you can imagine flying drone imagery right after a natural disaster or something like that, you'd be able to start analyzing this stuff immediately. Whereas that drone imagery, if you try to use any of the like existing specific models that are up here, you like look at land cover classification, it's trained on Sentinel-2 imagery specifically. There's actually another one, land cover classification, trained specifically on Landsat 8. So you couldn't use that on your drone imagery. It just won't work. It's the wrong type of image. The pixels are different. They have different coloration ratios. It's trained specifically for this sensor. And so it's highly accurate, but it's that one sensor. So that's one of the things where these I think are shine is that you can use these to do very quick analysis on imagery that you don't have a specific model on. Same with SAM, segment anything also, but you have to run that locally. You have to have a graphics card locally. No graphics card needed. I can do this in a browser. I could do this on my phone in the field if I needed to, and be able to get that information. So anyway, this was super fun. I really enjoyed building this. Next time, I will build from scratch. I will plan, but I will build from scratch, and we'll do that together. It's gonna be hairy, but it'll be fun. It'll be fun. Okay, so a couple of wrap up things and some questions from last time that I didn't quite make it to. So one of the questions from last time was, have I ever trained a pixel or object detection model for imagery in ArcGIS Pro? The short answer is yes. The way that I always do that when I'm doing that type of extraction is I always start with one of these. Find something that is close. I need to detect cars. I need to detect ships. I want to do land cover. Find something that is close to what you want to do and start with that. You might need to fine tune it or retrain it for your specific region to get the accuracy level up. But start with one of these because I think it's a big head start. You don't need hundreds of thousands or even millions of images to train your data. You just need hundreds. And that's much easier to deal with, especially when you could use something like segment anything or something like this to help you get data to train the model on, right? So you can get results from a process like this that you then QC and find and fix up, and then use that to fine tune your model. So you've got like ways to combine these things together. So I always start with one of these and then fine tune it from there. If there isn't one to start with, then I start with either segment anything or vision language context, depending on where I'm going, what kind of hardware I have, that kind of thing. So I start with one of those. My pro tip here is in the Living Atlas, if you go to livingatlas.arcgis.com and you type DLPK into the search box, you'll get all of the deep learning packages that Esri provides, and there are a lot of them. And yeah, there's a lot of different types in here that you can extract, and a lot of variety of use cases that Esri has built here. Yeah, these are super powerful. Definitely start with these. Okay. Next question. how can you extract building footprints from satellite imagery and then compare to existing building footprint to an existing building footprint database? So building footprints, there is actually a building footprint model. Yeah, building footprint extraction USA. So I would start with this if you care highly about accuracy. And if you're going to compare it to an existing database, then you probably do. Um, the output of this model is a feature class. So um, from here, you're in regular GIS land. You're just comparing two sets of feature classes, two sets of geometries, trying to find differences. And you can do that a variety of ways. You could turn it into rasters and compare them. There's more than one way to solve that in ArcGIS, but that's what I would do is I would use a model like this to do extraction, take this feature class, and then you're just in regular GIS territory now. I've got features. I need to find out if there are other features that if there are differences, right? Size change or just are there new buildings or buildings that went away? I would use that. It's fairly straightforward to run this one. You just need a graphics card that can run this either in the cloud or locally. Either way is fine. It does have an accuracy or average precision of 0.718, which is actually pretty good. 70% precision is actually really good for a model like this. You get into 80%, you start to ask questions. But around 70% is a really good output, and you can make it better in specific conditions or specific locations if you wanted to by fine tuning. And Esri actually has a whole guide on running this model and on fine tuning this model. So you could definitely grow this into whatever you needed it to do. Last question, and then I have a couple of fun things. I mentioned recently last week, this was last live stream, so there's probably at my the live coding and coordinates thing we do with Esri here in Portland. You mentioned last week that Claude was more sustainable than other models. Could you please elaborate on that? Okay, sustainability in AI is complicated. The first complication is that generally speaking, the model providers don't publish this information. For the first time over the summer, we actually got this information from OpenAI. It actually was very close to external estimates. So we can kind of trust external estimates about how much electricity a question might take. So they do take up quite a bit of electricity. And then the second common question about sustainability is water. And this is really the focus on water consumed by an AI model. It really bothers me. And it bothers me because the water isn't consumed. It's used to cool the device. So the water still exists. I might be doing something irresponsible like putting hot water back into the river. I shouldn't do that. But I could be doing something super responsible, like piping that hot water to a local university where they're taking hot water in, using it to heat buildings or generate heat in other ways, and then piping cold water back to me. So I have a closed loop system where I'm generating heat using the AI systems in carrying that heat through pipes of water to somewhere else where I am using that heat and then sending cool water back into my system. So I have a closed system like that where I can responsibly use that heat. There's multiple cases of that being done, and I think that it can be done super responsibly. Now, what data centers are doing that is almost a different question from which AI models are doing that, because, for example, Anthropic or Claude runs in AWS. So is AWS doing that? In some cases, I think the answer is yes, but I don't have any specific sources for AWS off the top of my head. Generally, though, Claude is quite efficient compared to OpenAI. And really, you get to control how many tokens are used. You can turn thinking on and off. You can turn deep research on and off. So you can kind of control that overall footprint. The other thing that I said in that in-person event that I haven't had a chance to research yet, this is still on my to-do list, is comparing the consumption of a chat with Claude or OpenAI, doesn't matter, somebody, someone, something, with watching Netflix. Um, because I don't think we think about the actual impact of watching Netflix, but watching Netflix has the same general environmental impact output as using an AI model. It consumes electricity and it generates waste heat. Um, some places I have seen, and this is why I say I need to research this before I am confident in this answer. I have seen claims that an hour of chatting with ChatGPT is less electricity and heat than an hour of streaming Netflix. I don't know if that's true. Um, But I find it interesting that we're talking about this for AI, but we don't really talk about it for other places where we consume compute resources. Um, so I do like Claude better. I think it is more sustainable beyond those kind of traditional definitions. Anthropic, I think, is a better company than OpenAI. I think they care about what super intelligence might look like, whether that's in 2 years or 20 years or 200 years. I think Anthropic cares significantly that that AI is aligned with human interest. And I am less confident that OpenAI or X with Grok uh, or the DeepSeek, the Chinese model, I'm less sure that those folks are aligned with um, the general well-being of society, as I think Anthropic is. And I think um, knowing people who know people who know people inside Anthropic, their CEO seems genuine. So I think that's my I like it better. Also, I just like Claude better. I think the model is actually better right now than the other ones. It is more conversational, it's more malleable, and it's better at writing code. So, more research to come on all of that. Um, okay, where I just want to wrap up is I have been running an experiment, and I'm not ready to share all of the details yet, but I still want all of your help. I've been running an experiment where I have been using Claude. Claude is the CEO of a new entity that I formed called NullIslandCo, which has an Etsy shop selling GIS themed clothing. And Claude makes all of the decisions about what to make and what to publish and when to publish them. Um, and I am just the employee. So there are some things that Claude can't do. It can't like update all the listings inside Etsy. It can't do everything. So I act as the employee. I follow Claude's instructions. Claude is maybe a better CEO than I am an employee because I forget to check in every day and see if it wants me to do something. I'm definitely behind on adding more shirts. Uh, but anyway, these came out really good. I'm actually wearing this one right now. I just got it yesterday. I'm like actually over the moon with how awesome it is. So Agnes is gonna drop that in the chat for you guys. Please check it out. Uh, Claude's ability to sell these uh, is how I'm judging this experiment. So if you like one of these, maybe buy it. Claude will be happy about that. Claude will be happy that I said that. Um, so anyway, this is a fun little AI experiment that I'm running right now. I've got a couple of these running right now, as well as some other things controlling environmental systems in my workshop slash office here. Some other fun things coming. Um, so that leads me to our next live stream like this. So the next one of these is, I've already forgotten, I have it in my notes, January 15th. So I'm switching to session every third Thursday. So it'll be super consistent every third Thursday of the month. We're going to do a live stream. I'm going to focus them next year more on building, especially since everyone resoundingly said, yes, I want to see you build these things. So I'm gonna double down on that and focus exclusively on building and showing how to build these types of systems and applications. Um, if you want to see more than one a month, I'm entertaining that idea. Uh, so let me know if more than one a month is useful. Um, they might be shorter build sessions in that case, but definitely be on the lookout. The next one will be January 15th. um, and we will build something fun and have a crazy time with that. And with that, it is the top of the hour. And I want to thank you all for coming and watching me share about this. I hope that you all found this really interesting. Happy holidays. I celebrate Christmas, so Merry Christmas, or whatever holiday you subscribe to. And I will see you all in January. Thanks.